Hello, let's start with our today's DSA Journey with this amazing visualizer by DSA.ChaiCode.com. Use this link to get a 7-day free trial. Okay, let's start with our today's question. And our today's is this one. Longest repeating character replacement. So variable window, invariant length, maximum frequency k. Given a string and a budget of k character changes. Find the length of the longest substring made of a single repeated character after performing at most k replacement. So the question is, this is our string and this is the value of k. So we have to find a longest substring where we can make one replacement or change. So let's suppose this is the longest substring. We have to make sure the substring contained only same characters. Here in this substring 3a and 1b, if we change this b to a, if we change this b to a, then we are using one replacement, and also everything is going to be a same character. So a and a, so 4, the size of the string will become 4. So this is our question. We have to make sure we can only perform k replacement into the string, into this whole array of characters or string. Then we can ensure we get a maximum substring. So if you go to the question here, it clearly mentioned you are given a string and an integer k. You can choose any character of the string and change it to other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring contain the same letter you can get after performing the above operations. Okay, so what could be our approach here? The brute force approach would become, we are using two loops. Okay, so this is our string, and let's suppose we are having a map where we calculate the value and the count of the value. Let's suppose how many number, and we start the map from the starting. So we start it from the starting and go towards the end. So at first the map contains a, let me just, at first the map contains a, next time a, next time a b, next time a b a, next time a b a b, and so on. So if we consider two loops, we can get this. So for each case, suppose in this case, suppose this is our case, this is our string, substring. So in this case, how many number of a is here for this substring? How many number of a is there? How many number of b is there? A has 3 times, b has 2 times. Okay, in this substring a has 3 times, b has 2 times. Now we have to think that how could we get a maximum element. So for this we can use this logic. Just bring me here, keep the character, keep the character that already appears at the most and change every other character. So what it means? It means if we want to make the whole substring into one letter, which is more efficient. So if we want to convert all the things into B, so there are 3A, 2B. So if we convert all the elements into B, we have to perform 3 operations. But if we want to convert every element into A, we have to consider 2 operations. Because there are 2B, if we change this 2B into 2A, then we can easily get a string. So which is more efficient? This one. So for this reason, this line appears. Keep the character that already appears the most. So A is most, so we take the A most, and the change in the other character, that that is B. If we want to convert B into A, we have to perform only 2 operations. We have to perform only 2 operations. Okay. But after getting the most frequency, so the size is 5. So the size of the substring is 5, and number of A's, or the maximum frequency, is 3. Maximum frequency is 3. Okay, so we have 2 elements left which are not into that maximum frequency. Now we have to change these 2 elements. We have to change these 2 elements into one single element. How could we perform this? Or is this possible? It is not possible because k is 1 here. So we cannot perform this because k is 1 here, and at most k operation we can perform. So it is not possible. So let's take another string, this string. So this is our substring. Here A has 3 and B has only 1 times. In If we want to convert every B into A, we have to perform 1 operation. But if we want to convert every A into B, we have to perform 3 operations, which is most easier, most simpler one because it is lower. So what is the max frequency? What is the total length? Total length is 4. Okay. What is the maximum frequency of an element? Which is 3. So now what are the remaining elements? 1. Can we change one element? Yes, because k is 1. So this is possible. And what is the maximum length? 4. 4, because we change this b into a and it becomes 4a. So this is our actual implementation. We calculate the maximum frequency of a substring, the max frequency and the length of the substring. If we subtract both of them, we get the replacement. If the replacement is equal to or less than equal to k, is replacement, this replacement, okay. So this replacement, if the replacement is less than or equal to k, it's mean valid string, and the length would become the length, and we can easily check maximum. Okay, but how could we achieve it? We use a map to store the index of every subarray. Okay, using 2 loops we can perform this easily, and then every time we calculate this value, this equation, which is nothing but length minus max frequency and replacement of k, and we get the replacement. If the replacement is less than or equal to the k, we can easily get our value. Okay, now visualize it. First, let's see it. You may replace at most k one character. Find the longest window, one replacement character. So we need a window. So we started from 0. J is also 0. We just increase it. Notice here how many elements are there? 2. So the length is 2. And what is the maximum frequency? 2, because A appears 2 times. So 2 minus 2, it becomes 0. And the k is 1. So it is possible. Then we again join. So the length is 3, maximum frequency is 2. So 3 minus 2 is 1, which is less than equal to k. It is valid. It is valid, and the answer increase because the length increase. If we again increase it, so A joins, the length become 4, the maximum frequency become 3 because A appears 3 times, B appears 1 time. So 4 minus 3, 1. 1 is less than k, and we get our best element. If we increase it again, so the length will become 5. The max frequency of A is 3 and B is 2. So 3 minus 2 is 2. So 2 is greater than k. So we broke the window and we increased the I. So we are using here two loops. And we again check it in the same way. The same way when we get the need greater than k, we got it. So let's write the pseudocode here, which is nothing but a function which takes an array, let's say, or s and a k, and inside this just take a best or maximum answer at the starting 0 for, let's take the initial loop, and inside it take a map which is nothing but an empty map of value and the count of the value. Okay, and then a max frequency which is nothing but 0, which is a frequency which we actually calculating here, the maximum frequency. Okay, now take another loop for j starting from I to n minus 1. Okay, from start to the end, every time increase the element in the jth index into the map, not the ith, jth. Okay, we are increasing the jth. So map of s of j plus plus, then we just easily calculate the maximum frequency here, which is nothing but a simple trick, which is uh, max frequency. It will become max frequency and map of s of j. Every step we are calculating which is our maximum frequency, and after calculating the maximum frequency, we have to perform this operation, length minus maximum frequency. First calculate the length, which is nothing but j minus I plus 1, and now if length minus maximum frequency is less than equal to k, so k is our index, so if less than equal to k, simply we just update our best or the answer, which is nothing but best, become max of best and the length. Okay, now if it's not possible, we just easily break it. If in any cases if it not possible, for that iteration we cannot extend it because it will not give us the answer. So at the end just return the best. Let's evaluate it. Yes, we nailed it. We nailed it. Now just come and write the solution. So this is our pseudocode. This is our pseudocode which you have to take. Now write the actual code here. First take the size, which is nothing but s dot is, and now take an answer. At the starting it is 0, and run a loop. It will start from 0 to n to I plus plus, and inside it take an ordered map which store the character into their frequency in MP, let's say. So the char and frequencies, and take a max frequency which is nothing but initialize with 0. Take a j loop starting from I, the last index, to the last index. Every time first increase the frequency count. Increase the frequency count. At the first we have to increase the frequency count, then get the max frequency, then calculate the length of the substring from I to j. Calculate the length of the substring. You have to calculate the length of the substring, then the replacement value, then check for valid replacement. Okay, so we are actually performing two loops to get every substring possible. Here we are taking a b. So in every loop we are taking every substring possible into the string. So first increase the count, so map of s of j plus plus, then get the maximum frequency, which is nothing but max frequency will become max frequency and the current MP of s of j. That if we encounter any frequency which is more than the current frequency or not in the previous, or this is the biggest frequency that we actually get of any character. Okay, so now calculate the length. So let's take it length, which is nothing but j minus I plus 1. We have to calculate the replacement value. So int replacement is nothing but length minus maximum frequency, to get actually how many element actually we have to replace. If this replacement value is become less than equal to k, it means it's in the range. We have to just update our answer. So the answer will become maximum of answer and the current substring length, and else we can easily break the loop anytime. So just return the answer. Okay, we are using two loop just to get every substring. We got a. Okay, we got a. We check, is it possible? We got double a. Is it possible? A b. Is it possible? Is it possible? No, because here are 2b and our k is 1. So this is our actual implementation. We are actually taking every substring from this whole string and then check, is it a possible string according to the condition. So let's run it. Let's submit it. It should give a TLE because we are using two loops to perform, and the time complexity will become big O of n square, and the space complexity, we are using a map every time. At max it could take big O of n. Okay, or 26 you can say, because only the characters are possible, only uppercase character actually given to us, so the map size will always become 26, because not more than 26 character we can insert, because only 26 character are there. So this time complexity will become big of n and the space will become big O of 26. Now go to our optimized solution. We can take a variable window rather than taking every substring. We can use a variable window. Okay, let's first check it. The variable window template, interval length minus max frequency of k, expand R always when the window needs more than k replacement. Contact L once. Okay, so when the window needs more than k replacement, actually here we are breaking the loop. In this case, we have to perform the L1. There should be two pointer L and R. We have to increase the L every time as our two pointer approach works. So first, starting L from 0, a frequency 0, answer is 0, maximum frequency 0, window is starting. So we start our window at the very first. Okay, at the very first we start our window, and we are just checking is it is the max frequency of the element or not. In the same way we are checking the maximum frequency. In the same way we are checking the maximum frequency. And when we check our maximum frequency, we just check how many replacement character using this same formula. We are checking how many replacement character using this same formula. And if it is in like out of range, we are increasing it, and if it inside the range, simply we just calculate it the answer, the replacement, as simple as that. So it is possible. Now increase our R, only increase R at the starting when there is no value exceeding k. Okay, it is possible. It's B. When the R is B join, the length will become 3. The length will become 3. The maximum frequency is 2 because A appears 2 times. So we need 3 minus 2, 1. And 1 is less than equal to K. So we can easily take it. We just take it, increase our length. Okay. For the next element, length become 4, maximum frequency become 3 because A appears 3 times here and B appears only 1 times. So 4 minus 3 become 1, and 1 is less than equal to K. 1 is less than equal to K, and it is a possible solution. So let's increase the length. Now for this case there are 2B and number of A become 3. Length is 5, A number of A is 3, number of B is 2. We cannot replace it because 5 minus 3 become 2, which is greater than K. So in this case, we are shrink our window. We just decrease our window size. How? We just increase our L. We have to first reduce the value of the L element. First we have to reduce the value of the L element, then we increase our L. Okay, simple as that. So now the frequency of A become 2, frequency of B become 2. So 2 and the total length is 4. So 4 minus 2, 2. We cannot perform anything. So increase it. Okay, increase it. Increase the R. Increase the R. L become 1, length become 4, max frequency stays 3. It may be stale, but the stale maximum only check the window never shrink below the best already found. Okay, so the base is always 4. So we cannot shrink our window. We cannot shrink our window less than 4. And how we ensure this? Because we are calculating the maximum frequency. And when we calculate the replacement, which is length minus maximum frequency in this formula, it always gives us 1. And the frequency is always of A become 3 because 3 become maximum. So again when we calculating here, the maximum frequency, the formula is simple: max of maximum frequency and frequency of S of R. Frequency of S of R become 2, which is B is 2, and the maximum is 3. So 3 minus 2 become 1. Yes, we can replace it, although we just checking the length, so it doesn't affect our solution. Although it is not a valid solution, AB not a valid solution, but we never reduce our length less than 4, because we already get a 4 length. If we reduce our length to 3, we don't need any smaller elements, we need more bigger elements. Okay, now increase the B here, and the B become 3, B become 3, and A become 2. So it's again 2 greater than K. And also check, actually the length become 5. So in this case we just simply increase our L. So here the maximum frequency of B is 3, okay, and A is 1. So 3, and the length is 4. So 4 minus 3, 1. We can easily change one element, and length is 4, and also in the previous case the base length is also 4, so we don't need to, we update the length according to, but it will not affect. Okay, so again we increase, and we take no, 2 less than K is not possible, so we decrease our L. So it is become 4 again, so L BBA, it will not work. So, and the return is the base is 4. So let's write the pseudocode here. A function which takes S and K. S is the string and K is the value. First take a map. Now the map will store similar thing, value and the count of the value or the frequency of the value. Okay, take the first pointer starting from 0. Take the maximum frequency at the starting 0. So for a for loop, for R started from 0 to n minus 1, it started from 0 till n minus 1. So first just increase the map value s of R plus plus, we just increase the value into the map. Now calculate the max frequency, which is nothing but max frequency and the current element, which is nothing but map of s of R. Okay, now we have to calculate the length and the replacement value. We can easily calculate it. R minus L plus 1 minus maximum frequency. So R minus L plus 1 is our length, and maximum frequency, when we subtract it, it will give us the replacement value. And if it greater than K, if it's become greater than K, then first remove the element from the map, which is S of L, map of S of L minus minus, and then L plus plus, and if it's not happens, that's mean it's already in the range, it's already in the range. So if it's greater than K, we just remove it, and without that it's already in the range. So the we have to take actually one answer here, which is nothing but take maximum length at the starting, it is 0. Take answer based maximum length, anything, and here just increase, just take the maximum length from this length, which is nothing but R minus L plus 1. Okay, and here we have to take L at the end also, and return the maximum length. Now just evaluate it. So this is our optimized approach pseudocode. This is our optimized approach pseudocode. We are actually using one loop here, just one loop here and nothing else. So let's code it down. first take the index, which is nothing but s dot size, the last index. Then take a map as usual, which is nothing but character and integer. It will store character and the frequency of the character. So first we take an L which is starting from 0, then we just take L, another max frequency which is nothing but the maximum frequency we can get. At the starting the maximum frequency will become 0. Also one answer which we can take maximum length, at the starting it is also 0. So now make another loop which is nothing but int r starting from 0, r less than n, r plus plus. So it goes from the starting to the end of the loop, and inside the loop first add the element to the map. First we add the element to the map, then update the maximum frequency, check the replacement, and update according to replacement. Okay, now first add the element to the map, which is nothing but mp of s of j plus, sorry, not j, it is r, mp of s of r plus plus. Now calculate the max frequency, which is nothing but maximum of max frequency, and the current frequency, which is nothing but mp of s of r. Okay, it should become r. Now we have to calculate the replacement, which is nothing but if r minus l plus 1 minus maximum frequency is greater than k. Okay, if it's greater than k, this comment should go up. If it's greater than k, we have to actually remove the element from the starting and then increase our pointer from the starting. And now for every cases we have to calculate the maximum length, which is nothing but max of maximum length comma r minus l plus 1. So why we not calculate this value at the starting? Because if it goes inside this if loop, if statement, it just increase the value of l, and we need the updated value of l. For that reason we are not taking the length or anything here, and at the end just return the maximum length. It's working, let's run it. Yes, it's working. So we are actually taking from the start to end, so it only one loop works, so it takes big O of n as time complexity, and we max to max insert 26 character because the alphabet has 26 character. So we can easily say this time complexity of this code will become big O of n, where n is the size of the string, and the space complexity will become big O of 26 because only 26 characters are there. Okay, so also time complexity is big O of n, space complexity is big O of 26. So this is our question, longest replacement character. Okay, so go check this out, check the platform using this link to get a 7-day free trial. Use this DSA platform, it is amazing. Thank you very much.